Module 7, problem number 10. The multiple regression equation y hat equals 10 plus 3x1 minus 4x2 is obtained from a set of sample data. Complete parts A through E. Part A, interpret the slope coefficient for x1. Choose the correct answer below. So first we can go straight to our equation here and see that the number right in front of x1 is 3. So we know that our slope coefficient of x1 is 3. So that tells us that we're already looking at parts A, or answers A or C, not answer B, since it says the coefficient is 10. Now next, it talks about this indicates that y hat will either increase or decrease 3 units for every 1 unit increase in x1, while x2 remains constant. So remember, when we're looking at interpreting the slope coefficients, we're assuming that the other variable, x2 in this case, remains constant. So for every unit increase of x1, since 3 right here is a positive number, we know that y hat will increase 3 units. Now, if that was a negative 3, it would decrease 3 units. So since it's a positive 3, this indicates that y hat will increase 3 units for every 1 unit increase in x1. x2 remains constant. So that's answer C. Interpret the slope coefficient for x2. So similarly as how we did for x1, we're going to look at x2 now. So here our x2 is a negative 4. So we can already, again, cross out answer A and look at just answers B and C. Now remember, in part A, we already talked about if the slope coefficient is positive, that means that y hat will increase for every unit increase of that variable. In this case, we have a negative, so we know that y hat will decrease that number of units. So in this case, we're looking at the slope coefficient of x2 is negative 4. This indicates that y hat will decrease 4 units for every unit increase of x2. x1 remains constant. The only option was here where it says decrease 1/4 units. There's no reason for that. It's 4 units, as you can tell. Good job. All right, determine the regression equation with x1 equal to 10. Choose the correct answer below. Okay, so now let's look at our equation here. So here in this case, we're looking at, again, when x1 is equal to 10. So here's our original equation. When x1 is equal to 10, we have y hat equals 10 plus. We just need to plug that 10 in for our x1. We're assuming x1 is equal to 10 in this case. So we have 3 times 10 minus 4x2. Nothing changes for x2. So now we have y hat equals 10 plus 30 minus 4x2, or y hat is equal to 40 minus 4x2. So let's take a look now. Plug that in, or excuse me, check our answer. Well done. All right, so now we're going to be looking at the graph. So assuming that x1 is equal to 10, we're looking at that equation. We have it right here from the previous problem right there, 40 minus 4x2. So that means that our x-axis is x2 and our y-axis is y. Now, one thing that we know is that when we have a negative slope, that means that our line is going to be traveling this way. As you see here, as x increases, y decreases. When we have a positive slope, you see that as x increases, y increases. So we already know that C is not the answer because it's got, this graph shows a positive slope, whereas our graph, we know, should have a negative slope. So again, let's take a look at our intercept. So when x2 is equal to 0, what does y hat equal? So when we have x2 equal to 0, we know that y hat should be at 40. Here we can see that y hat is at 80. Let's just double check this one by opening it up to make it a little bigger. As we can see here, that y hat is equal to 40. So our intercept is at 40 and we have a negative slope. So we can now say that B is our graph representing that equation. Fantastic. Let's go to the next one. And as some of you who already went through this know that you're going to just check the different x1 values. So now we're looking at determine the regression equation with x1 equal to 15. Choose the correct answer below. So now we are looking at x1 equal to 15. So here we have plugging in 15 for x1, just like we did in the previous part with x1 equal to 10. we have y hat equals 10 plus 3 times 15 minus 4x2, or 10 plus 45, because 3 times 15 is 45, minus 4x2, and that's 55 minus 4x2. So let's check that answer. Excellent. Now let's take a look at that graph and see. Graph the regression equation and choose the correct graph below. Now again, we are still looking at a negative slope. Nothing's changed here on our x2 coefficient. So we still have a negative slope. So we know A is not the answer. We still have this negative slope. Now if we were to plug in 0 for x2, we would get 55. So that means that our y-intercept should be 55. Now, just looking at this, I can tell this is way too close to the x-axis, too close to 0, 0 to be at 55, but let's just double check. So you see here, it almost looks like it's at 5 would be your y-intercept, which we know is not the right spot. We need to be at 50. So here, this one's up here at 50. So we know C is the answer. So let's continue. Determine the regression equation with x1 equal to 20. So just like we did for the last two, we're just going to be plugging 20 in for x1. So here we have 10 plus 3 times 20 minus 4x2, which is 10 plus 60. And so 10 plus 60 is 70. So we have y hat equals 70 minus 4x2. Let's check our answer. All right, now let's take a look at that graph and see which one we're looking at. All right, so again, our slope doesn't change. Our slope is negative. All three of these are negative. So now we need to take a little closer look at the y-intercept. In this case, let's plug in 0 for x2. So now we know we have a y-intercept of 70, because 70 minus 0 is 70. So here again, this one looks way too close to the 0, 0 point. This is not the answer. This one doesn't look like it touches the y-axis at all before 80. So that one is likely not the answer. Let's take a look right here, because this looks like it's really close to 70. Let's open it up. Yep, it is right there at the 70 line. So we know our y-intercept here is 70 and our slope is negative. So let's take a look, double check. Nice work. All right, what is the effect of changing the value x1 on the graph of the regression line? Well, it's not that there's no changes, because we definitely saw changes in the graph. Changes in the slope, now we talked about that. For every single one of these graphs, our slope was -4. That never changed because that was the x2 coefficient. What we did notice is that the graph, the line seemed to move up and down on the y-axis. That was depending on where the y-intercept was. So changes in the y-intercept. Well done. All right, if you have any questions about that, let me know.